A good morning, good afternoon, or good evening, depending on where you are, and welcome to this Ask the Team for Azure SQL Database. This session will cover over the next 60 minutes or such a number of questions, and that attendees are welcome to start typing in their Q&A panel. So we will do quickly a team intro and what to expect in this next 60 minutes. And then, we will close up, leaving with some interesting links for you to follow up on Azure SQL Database and connecting topics. Just a few kind of rules for engagement. Again, please use the chat box to ask questions. You can post questions anonymously, or you can use your real name, whatever you prefer. The questions will appear, will pop up once we will go through them, and we will approve, just to avoid some bad text or stuff like that to pop up to everybody. You can upvote your favorites. Your favorite questions by using the thumbs up button, and this will basically pull them on top of the queue. We will try to answer verbally as much as we can in these 60 minutes, and we will of course answer the most popular ones first. Please, don't just spam or create content and questions that don't adhere to the Microsoft Code of Conduct. I'm sure you have seen this before over the last couple of days, and let's move to present ourselves. My name is Silvano Coriani. I'm a program manager within the Azure SQL Database team, where I'm working mainly on the developer experience part, and I'm focusing specifically on the European region. And I've been working on SQL technologies since I would say the last 25 years or such. Over the last 10 years, I've been part of the SQL customer advisory team, working on some of the more challenging and complex projects, with working with customers and partners in the field. And I leave the stage to my colleague Balmukun here to present himself.
Hi everyone. Good morning, good afternoon, good evening, based on the time from where you joined the session. And my name is Balmukund Lakhani. I'm also working as a program manager based out of Bangalore, India, taking care of customer across APAC region. And I am working with SQL product since past 20 years and spent close to 15 years with Microsoft supporting SQL Server product. And along with me, we have Borko. Borko, over to you.
So thank you. My name is Borko Novakovic. I'm the principal PM manager in Azure SQL, part of the Azure Data team in Microsoft. I'm 9 years with Microsoft. Last 3.5 years, I'm the leading program manager for Azure SQL Managed Instance, the new deployment option that is created for you to modernize existing SQL Server application in Azure Cloud. And prior to that, I also worked as part of the Azure SQL team and SQL Server teams on some of the interesting features like temporal tables, query store, automatic tuning, JSON. Prior to Microsoft, I spent almost 10 years working in software industry, and spent a lot of time working with SQL Server, especially on the business intelligence stack. We basically created BI solution on top of SQL Server and Microsoft stack for a finance industry vertical. Yeah, that's about me. Thanks.
Okay, so let's move to what you can ask us about. There's a kind of a long list here, and we will start going through the live Q&A panel soon. But in general, the topics that we typically work on and that we are experienced on are still, as I said, on the development side. How to connect and to use SQL database from the different programming languages and frameworks, how to use from an application developer perspective column stores, the new graph capabilities, JSON capabilities, and so on. We can answer questions around different kind of workloads that you can think about connecting to a relational database service like a SQL database. The various deployment models we have in Azure SQL DB, all different flavors in the managed instance, serverless, elastic pools, and around high availability, disaster recovery, the different features that we have in place. Also, security and data protection. These are all topics that we are happy to start discussing. And I'm starting to take a look here at the live Q&A panel, and I will play the kind of this jockey role here. And if my colleagues will want to jump in at any time, they are free to do that. Otherwise, I will probably drive some questions to them to see if they can answer better than what I can do. There's one of the most popular questions here is related to Azure SQL Database serverless. And the question is there a plan to allow automation on the start and stop of the serverless database? The serverless today does provide the ability to auto-pause after a certain time interval. Today, that time interval is 60 minutes. And we are planning to reduce that auto-pause time down to a few minutes. But as of now, we don't have a plan to basically start manually or through some sort of automation or APIs that database instance. This is, by the way, a good suggestion, a good feedback that we can take back to the feature team, which is working on that. So we will take this as a great feedback for the next planning phase. That another good one. What is most cost effective, Azure Cosmos DB or Azure SQL? I'll give you my personal experience on this, and then my colleagues can jump in if they have some some different feelings or information. Both are targeting different workloads, right? Azure SQL DB and is a relational database engine. So it has all the strengths and weaknesses of a relational database. Depending on the kind of interactions that you're having, you may find Cosmos DB, which is a NoSQL store implementing several different front-end APIs from SQL to MongoDB to Cassandra. You may find that more effective than SQL, and vice versa, right? So I would say there's no absolute kind of more cost-effective winner here in the battle. It really depends. If you need to query your data and do a lot of kind of analytics type of workloads, Azure SQL DB is probably more effective thanks to the kind of really fast and evolved query processor that Azure SQL DB has that is very effective in figuring out what is the best way to retrieve data from the storage engine. On the other hand, if you have a lot of data to ingest, NoSQL stores and Azure Cosmos DB can definitely be a better choice in this regard. It depends. It's probably the best answer that we can provide here. Let me take a look at some additional questions here. What exactly is happening when I scale a database up or down, increasing or decreasing the DTUs? Borko, do you want to take this one?
Yes. So basically, I just first want to comment that there are different deployment options in SQL database, several single database, and managed instance. But basically, the mechanism is pretty similar across these three. So basically, when database needs to be scaled up, let's say in terms of more compute, adding more DTU, what happens is that the resource manager on the node or the virtual machine, when the database is placed, he'll figure out first if there is enough compute capacity to give the additional processors to the SQL process. And if there is additional space or additional compute available, then basically database can be scaled up pretty fast. Now, if on that particular node, when the SQL database is currently running, there is no free processors to be assigned to the database, then the basically service fabric load balancer component that is coordinating workload across multiple virtual machine and nodes will find another machine where there is enough compute. And then the new SQL Server process will be started there. And then depending whether you are using standard or business critical service tier, standard is basically using remote storage, whereas business critical is using local storage, the database will be either attached or replicated to the new process. During this process, your application is still up and running. You don't see any glitches, any connectivity issues. And then only in the last step of this process, the internal failover happens. So basically your connection endpoint is being redirected to a new SQL process with a more or less DTU, depending on what you ask for, right? During that process, which can take a few seconds, your connectivity, you can experience some connectivity, basically some connection can break. But however, thanks to the drivers, latest drivers that we suggest you to use, basically these drivers have the connectivity resilience. So they will retry, they have the built-in retry logic, they will retry the connectivity and your application will continue working on with a new updated, scaled up or down database, basically without any glitches. So that's what happens in short behind the scenes. I hope that helps.
Great, thanks, Borko. Let's continue to go through the list. And by the way, if you guys have some questions that you will see in the Q&A list that things are great to respond, please jump in. I'm gonna pick up a new one here. Okay, will Azure SQL Database ever get a Polybase-like feature? Or does this already exist? If so, what is the best practice for doing something like this? A good question. This is from Matt. Right now, from Azure SQL Database instances, you can bulk insert data that are stored in Azure storage, right? So you can do the bulk insert referring to an external data source like Azure Storage, Blob Storage, and defining what are the kind of details of where the files are, and all the other typical bulk insert details that you have to configure, and then you basically Azure SQL DB instance will pull the data in and will insert them into a table. Which is a typical scenario for which we use Polybase, for example, in Azure SQL Data Warehouse or Synapse Analytics. Polybase comes with a certain kind of machinery behind the scenes, which is kind of typically distributed into a number of nodes, scale out nodes. And this is, for example, what in Synapse Analytics gives you the ability to get the best performance when you're reading from external data sources like Azure Blob Storage or Azure Data Lake Storage N2. We don't have a plan for Azure SQL Database to implement the Polybase as it is in Azure Synapse Analytics today, but we are working on a feature to basically achieve the same results in Azure SQL DB in the next future. So today you can do the bulk insert in a single instance. Tomorrow you will be able to use something which resembles Polybase, but will have different characteristics behind the scenes in the way we implement that.
Silvano, if I may add, because I have some details around that. So yes, exactly, we should distinguish two things: Polybase technology and Polybase, let's say, API. So yes, there are considerations to implement Polybase API, namely external tables and external data sources. However, the underlying technology may be different, but our plan is to provide functionally same thing, and hopefully even with a better level of performance and scale up and scale out. Yeah.
All right, there's a question about the from Ed, which says, what is the best option for Azure SQL automated backup for days past automatic backup option? So I think the question is, by default you can do, the retention is 1 to 35 days, but there is an option called as LTR, which is long-term retention, where we will keep the backup for the database in the container, in the Azure Blob container, up to 10 years. So if you go to portal and look for option called manage backup, there you can say configure the policies, and over there you can go up to 10 days backup. We will keep it for you if you want to restore. So I think, yeah. Anything you want to add, Silvano, or something?
No, I'm just looking at another question that is very close to my heart. Can you tell us something about log.io and data.io, any improvement? For example, after 8 cores, it does no longer scale in vCore Gen 5. Also, any plan of raising it higher? This is super important, especially when you're designing applications, to consider how things are actually happening behind the scenes, right? So as Borko was mentioning previously, we do have different deployment models and different also service tiers, right? For example, we have DTU-based deployment models, we have vCore-based deployment models. We also have service tiers or performance tiers like general purpose, business critical, premium and standard and such, right? So they have different characteristics in terms of how they are accessing log and data files behind the scenes. For example, in business critical or premium deployment models, we do have data files and log files that are sitting in local SSDs. This means that these files needs to be replicated on all the different replicas that we create automatically behind the scenes for HA purposes, right? This also means that we need to introduce some governance in terms of how the SQL Server engine is accessing storage to be able to guarantee that data will get properly replicated in a synchronous way to our replicas, again, to make sure that we can guarantee durability and consistency of the data behind the scenes, right? This means that at some point, in typical workloads, depending on what characteristics your workloads have, you may encounter some limits. These limits are documented for the different performance tiers, the service tiers that we have, and generally speaking, are typically more governed for what for the log throughput, which is the most critical portion of the I/O subsystem in a database service like this, right? So This means that, yes, we are constantly working to improve our data and I/O throughput, but there will always be some limits, and the limits are intrinsic in the system design and in whatever system design you will come up with, right? So our recommendation, there are a lot of kind of performance-oriented documentation items and white papers that are explaining how you can get the most out of the different I/O and data levels that we implement in different service tiers. But generally speaking, our recommendations are always the same. Try to make your workload as efficient as possible. For example, if you have a variety intensive workload, try to batch multiple I/O operations, multiple database operations into batches. Group them into begin, commit, tran blocks is already a great way to reduce the pressure on the log I/O requirements that you have in your database instance. There's a white paper which is called How to Implement Batching Techniques in Azure SQL Database. I encourage you to go and search for that on the internet. It provides a number of great techniques on how you can make your workloads way more efficient in the way you are treating basically your backend instances, and you can actually save also a lot of money by making your workloads more efficient in the way they do IOs behind the scenes. So in the cloud, this is making a bigger difference than what usually happens on-prem when you are already pre-provisioned your server.
Thanks, Silvano. There's one question related to migration, and that's kind of my area, so I'd like to answer it. How can a big database be migrated to Azure SQL? Do you have a tool for that? So Azure SQL is a portfolio of SQL products that consist of virtual machines, single databases, and managed instances. And depending where you go, definitely you can go with the different database sizes. With the virtual machines, you basically literally go and migrate super large databases, tens of terabytes, basically using the virtual machines available and remote storage that you can attach to it. Now, when it comes to platform as offering, where we have single databases and managed instances, depending on which service tier you're using, you can migrate different database sizes. In business critical, single database and managed instances, you can go up to 4 terabytes. In general purpose service tier, with managed instance, you can go up to 8 terabytes. And finally, there is a service tier that is created for super large workloads. We call them hyperscale. It's currently available only for single databases, but we plan to expand its presence to other options. With the hyperscale, you can migrate your database up to 100 terabytes. So basically, very, very large database. Now, when it comes to tools, suggestion for you would be to use Database Migration Service, or DMS, which is an Azure managed service created to optimally move your data depending on your source and target. And the DMS allows both online and offline migration. So offline migration is migration with a allowed downtime, where an online migration allows you to migrate your application from your original environment to cloud with a minimal downtime, typically a few minutes.
Thanks, thanks, Borko. And by the way, I was noticing a follow-up question on the log I/O throughput for managed instance. I think this is also your area, right? So I don't know if you can provide some good details about that.
So can you read the question loudly?
Yeah, absolutely. Yeah. So can you also answer the log I/O throughput question for managed instance, please? We want to lift and shift without refactoring, but the log throughput, the limit is limiting. Any plans to increase it?
Yeah, that's a great question, and I'm the right person to ask that question. So yeah, there are some good news in that regard. When it comes to business critical service tier 40 vCores and above, we already increased the limits to 96 megabytes per second. Originally, it was 48 megabytes per second. And we plan to also give some increase to the lower business critical service tiers. So that's please stay tuned. It's very close to be released. Now, when it comes to general purpose, that was quite low, that had quite low log throughput, 22 megabytes per second, you can there expect significant improvements across the board. There were two issues there. Basically, the log throughput was capped starting from 8 vCores and above. We wanna introduce more linear log throughput row up to 40 vCores, and then you can. I think it will be realistically to expect 2 to 3x at least increased in the I/O log rate for the general purpose. So please stay tuned. A lot of good things are coming. Hopefully in several weeks from now. We will also create a blog about that, and we'll be very loud about these improvements.
Thanks, Borko. There's a good question here, which is I heard many times from customers and partners I've been working with as well. So with SQL database getting so performant and higher SKUs, many customers are confused about when to choose SQL DW, aka Azure Synapse Analytics, and SQL database. This is a great question, by the way. My answer typically to this is, again, look at what your workloads really needs to do. Azure SQL Data Warehouse or Synapse Analytics is a MPP, so a massive parallel processing architecture. Right? This means that your databases are distributed across a number of nodes that in parallel will execute distributed commands to basically fulfill your queries. Right? This means that if you have a large scan, talking about terabytes of data to scan to respond to a certain query, Synapse Analytics or SQL DW is the tool for you. At the same time, this distributed engine requires some overhead, of course, because the query query plan needs to be implemented in a different way. You have a lot of machinery to spin up before being able to respond to query. So this means that typically the interactive type of workloads are less are less optimal in this architecture compared to SMP systems like Azure SQL Database in all the different flavors. So managed instance, single database pools, and so on. Another aspect is concurrency. In Synapse Analytics or SQL DW, you have a very well-governed mechanism in order to define what queries are actually consuming most of the resources. You have these concurrency slots that are basically slicing and dicing the amount of resources available and are preventing some queries to actually impact others. In Azure SQL Database, you typically are hosting workloads that are more in the OLTP or in this HTAP, or this is the new buzzword, hybrid transaction analytical processing type of style, which is basically a mixed type of workload. And in that case, SQL Database can definitely do a great job. But again, if you have the 50 terabytes, 70 terabytes database sitting in SQL Hyperscale, and you have to do a large scan, in this case, the SQL Data Warehouse will definitely do a better job in responding to your queries.
So Silvano, maybe if you allow, you can also expand. I don't think it's always one versus other, right? There are solutions in actually where you can use both, like DW for the central big data warehouse and the database, SQL database for feeding and powering the data marts with a large number of concurrent users. Do you agree?
Correct. This is absolutely correct, and we have a lot of examples actually of customers combining the two in both the, let's say, ingesting layer, basically where data are coming from a data lake through some transformation steps that you can execute in Spark, for example, for Databricks or for Azure Synapse, but also in the serving layer, right, where dashboards from Power BI typically are connecting. This is a way, for example, to promote concurrency. If you have a lot of concurrent users, you can have a data mart layer which is serving data to this dashboards and Power BI reports, where data are effectively coming from Azure Synapse database in the backend. So yeah, I completely agree. It's typically a combination, but in general, this kind of decision point where you have to pick up one or the other. It's very important to determine what kind of workload you are going to run.
Fully agreed. There's one popular question from Jack. Are cross-database SQL queries going to be allowed in Azure SQL? Maybe I can answer that one. So just wanted to know, just wanted to let you know that cross-database queries are currently supported in Azure SQL Managed Instance, which is a flavor of our platform as a service offering. And you can use both the cross-database queries for the database that are part of the same instance, or using the link server databases that are sitting on different instances. Basically, we refer to these queries as three-part names or four-part names queries. If you need to run the cross-database queries in single databases, you still would need to use the Elastic Queries technology. It's possible, but the interface is a little bit different.
Great. So there are a lot of great questions, by the way. Thanks, folks. It's going to be hard to be able to answer all of them during this one, but the amount of questions that you are posting is definitely unbelievable, and all of them are very high quality. So thanks again. Let's pick up. There was one, probably the first one that came in, which was about COBOL. So how can I connect COBOL applications to Azure SQL Database? Is that possible? Actually, it is totally possible. There are different ways of running COBOL apps in Azure. Historically speaking, we've been hosting different native frameworks running on Windows technologies that were able to run COBOL programs and connect to external data sources through, for example, ODBC libraries. So if you have ODBC drivers in your COBOL apps today, you can definitely use them to connect to Azure SQL Database. If you're instead are hosting your COBOL code within some abstraction frameworks like, for example, .NET, there are great partners like Fujitsu creating, COBOL.NET compilers for running your COBOL code. Then you can use whatever library supported in .NET, like system.data.sql client, for example, to access Azure SQL Database. And again, it's totally possible to use Azure SQL DB from whatever programming language you want. Today we have data access libraries for pretty much every language on the planet, and we are keeping an eye on the new emerging ones to make sure that you can connect your apps to all the different Azure DB flavors we have on the platform. Another good one here is, this is a relatively simple one. How are platform upgrades to new version of SQL Server communicated to end users? How can we prevent app outages during those upgrades? So first of all, Azure SQL Database as a PaaS platform is taking care of a number of aspects related to version upgrades for the SQL Server engine and for all the other components of the platform. This means that the platform itself is taking care of doing this upgrades without basically you noticing any specific downtime for this. On the other hand, since a few years ago, we are moving into this concept of basically compatibility, application compatibility levels that you can set at the database instance level or at the server level, and essentially all the kind of the breaking changes, or I would say all the new improvements that are coming into the engine or into correlated technologies will be basically enabled in your databases the moment you are switching compatibility levels to, for example, the latest and greatest ones, right? So in that case, again, what we are doing behind the scenes, we are relying on the high availability architecture that we have in place for Azure SQL Database to make sure that we are minimizing the impact of these upgrades to you by introducing these new versions into our connected replicas, first of all, and then basically failing over from the primary to an updated replica so that essentially the perceived downtime for you is just a few seconds that we are taking behind the scenes to do the switch. Right, so this is the way we are maintaining, our high SLAs, and at the same time providing behind the scenes updates and patches to the platform. Okay, let's go through some of the newest ones. Oh, this is another good one, and I would say out since quite some time. So, is multi-region active configuration possible with SQL Azure? Not today. So all our different configurations and deployment models we have today are not supporting active multi-regions or multi-master, I would say, configurations, like, for example, Cosmos DB is offering. This is a topic that is out in SQL Server, I would say, since quite some time. Of course, we are working behind the scenes on understanding how to implement these kind of capabilities at best, but we don't have any plan to announce it now. Although you can kind of rest assured that this is a topic and a kind of a question, and that we are hearing from you, and we will continue to work on that to see if in the future will be possible to actually implement that capability.
I see a question from Johan. Best way to automate the backups from Azure SQL and restore on-premise instances.
Right.
So yeah, definitely I can tell one thing when it comes to Azure SQL, as I said, is umbrella for three things: virtual machine, SQL database, and managed instance. So you can take the backups from virtual machine and restore on premises. However, in our platform as a service offering, which is a single database and managed instance, it's not possible yet, because of the simple reason SQL database and managed instance are running how we call it evergreen version of SQL Server, which is the latest and greatest version. And by definition, you cannot take the backup from the latest version and restore on the previous or older version of SQL Server. This is currently not possible. There are some thinking how that could be possible. I cannot disclose details. However, that doesn't mean that you are locked, because you can either export data using the backpack and import on premises, or you can use, for instance, in managed instance case, transactional replication and snapshot replication, and take data that way from a managed instance to your on-premise SQL Server.
Great, thanks Borko. And another question that I'm very familiar with is, are you considering an API layer for querying Azure SQL DB? There was something in the past with OData. Yes, that is correct. We used to have a configuration option for SQL Azure a long time ago, actually, to basically expose an OData endpoint for every Azure SQL DB instance. Based on the feedback and the usage that we have seen with customers, at some point we decided to kind of deprecate that. But at the same time, there's full of documentation, both on the Microsoft official docs and on blogs and such, on how to quickly and simply implement the API layer for Azure SQL DB. OData is a great protocol to actually enable that and be able to navigate across your data within Azure SQL DB. I recently presented a session that you can probably find on YouTube on the Data Platform Geeks event a few days ago, and showing how to do that, for example, with GraphQL, which is a relatively new and exciting data protocol that you can use actually to query your data structures and data stores from your application and from your front ends. And again, it's literally, you can implement such an API endpoint with literally few lines of code. So although we are still considering this as a potential future improvement, we don't have a strict plan for doing that now, because again, you can actually deploy your own in minutes. But that's a great feedback, by the way.
One question which has come up from John, which says, what are the advantages or disadvantages does Azure SQL Database has compared with an on-prem installation? So I think we can simply answer this question by asking you to compare something between something between a PaaS offering versus an on-prem offering. In PaaS offering, all you need to do is just purchase a database, which means you need not worry about the installation, about the hardware, about the patching of OS. You don't need any administration required for that. All you need to do is focus your energy on writing a code using which you can create applications, rather than worrying about the licensing cost of SQL installation, maintaining the power for the machine and the cooling for the machine. So it is more about software platform as a service versus on-prem installation, where you have full control versus you have less control. You have given control to the vendor who is giving the offering to you, and you have taken you need to do only the work where you have to spend your energy and everything in making the application perform better, rather than worrying about the software being used in the backend and stuff like that. So I think I will give a supporting link in the answer on the question to you as well.
Thanks, Malbukun. Let's go through.
So maybe I can take this question on Azure SQL Serverless. How do I determine if I set the max peak or at the optimal value? So basically, the point of serverless is actually that you don't need to take care a lot about these things, because the only thing you need to specify is your minimal vCore usage and maximum vCore usage. But actually, you'll be charged only for the actual usage. So that's the beauty of serverless. If you predict that for instance, your workload can spike up to 16 vCores, you are free to set the 16 vCores as a max value, and then just set the minimum value that you will be comfortable with. However, as you can see, and there is tomorrow and today, there are a couple of sessions related to serverless. You'll see that you'll be charged on per actual usage and on per second basis. So yeah, definitely just determine what is your maximum value that you can spike to, and feel free to set it.
Great, thanks a lot. There's a question here from an anonymous, which has received 5 upvotes. So will there be a time in the future where Azure SQL will provide most of the SQL Server features? Since SQL Server can also be hosted on VMs in Azure, in which case Azure SQL is a better choice than SQL Server. Please tell in which case mission critical transactional database or analytics database is better suited. Again, the benefits that were mentioned previously around kind of managing your own instances versus going through a PaaS service, I think should be clear to anyone right now. In SQL Server deployed on a VM, you have full control. You can implement whatever configuration you like, and if you already have experience in managing large-scale SQL Server deployments in your own environment or in Azure VMs, that can be a great choice. But you, at the same time, you have the responsibility of managing everything. On Azure SQL, what we are doing is we are constantly improving the options that we have available for running workloads in a PaaS environment, where we are again taking care of everything from availability to upgrades and to all the different new capabilities that we are putting in place. So the answer to your question is it really depends on what you need in terms of trade-off between special configurations that will always be available in SQL Server deployed in VMs versus reducing the management costs. At the end of the day, you have the answer to this, because there will no an absolute answer here, and features like or deployment models like Azure SQL DB managed instance is actually a great kind of option in between these two, and we will see more and more kind of innovations coming in this space to make sure that you can configure your systems or use the features that are fully available in SQL Server, even if you are running in a PaaS platform. Oh, and again, a lot of other questions related to Azure SQL versus Cosmos DB or NoSQL stores. This is an interesting one from Dayan. So basically, can you recommend using Azure SQL over Cosmos DB with, say, Elastic Pool? How well is sharding, geo-replication, etc.? What would be the user/size limits you would recommend switching over to NoSQL? As I said previously, I don't think it's a size, I don't think it's a data volume problem here anymore, at least. Maybe it was like 7-8 years ago with Azure SQL. Right now, we effectively don't have limits in terms of size. We have different flavors that behave differently. Azure SQL Database Hyperscale, for example, will have no size limit, so it doesn't really matter. And if you have workloads that can benefit from the relational aspect of Azure SQL Database versus what is available in Cosmos DB today, which is, remember, kind of a NoSQL store, so typically works great for specific type of query patterns, then you can go with Azure SQL. Azure SQL also provides a lot of interesting capabilities related to, for example, how you spread data around. For example, in Hyperscale, we are doing the sharding for you behind the scenes into this new architecture for the storage engine. You can still have control and implement your own sharding technologies using, for example, Elastic tools and libraries in traditional Azure SQL databases. So options are there. It really depends on your workload. What I would say is that if you don't have specific query requirements and you are only ingesting data and accessing data for kind of key lookup type of queries, Cosmos DB is doing actually great. If you have query requirements that are more complex, this is where Azure SQL or a SQL relational engine is typically doing its best.
All right. There's a question about, is there any way we can limit the resources for certain users in DTU model or vCore model? So the governance is done by the SQL itself on based on what you purchase. There is no further bifurcation which can be done. So essentially, I think that the question is, can we do resource governance like we have in the on-prem? And I think the answer is no. Is that right, Silvano?
Just to add one thing, that's partially true in Azure SQL Managed Instance. Basically, Resource Governor is fully supported as on-premise. Okay. So yeah, so again, to Silvano's previous point, I think Managed Instance is a nice balance for the customers that look both for the manageability, easier manageability, and surface area that is close to on-premise SQL Server, right?
Definitely. So let's see. Lots of questions are coming in, and
there is an easy one for me. Any plans for geo-replication in hyperscale instances? Yes, there are plans. You can expect this coming.
I'm trying to look at also the new ones so that we can easy continuous. This is an interesting one, by the way. Easy continuous deployment. Is there a way to roll back if deployment phase in later stages where the DB upgrade changes already succeeded? What is the best approach for this? We actually recognize that there's a gap in terms of especially documentation and guidance on how to integrate Azure SQL Database instances into your own continuous integration, continuous deployment pipelines, and you should expect over the next few days. There's a great white paper that our team is working on and will be out over the next few days on what are the best practices in that regard. And of course, it depends a lot on how your kind of team development process is actually done. Yes, there are ways to actually let's say improve the way you are deploying changes in your databases. Clearly, rollback operations when you are changing the database, and this change is behind the scenes is triggering a lot of logged operations. Typically was taking a lot. Now with kind of the advanced recovery capabilities we have introduced recently with the latest compatibility levels in Azure SQL DB as well is helping a lot, because in that case recovery, if you are basically if you are wrapping your database changes within transactions, then the advanced recovery capabilities we have in place will minimize the amount of time rollback will take in order to basically bring back the previous state in your database, right? So this is a recommendation here is to go with the latest compatibility models to have ADR enabled for your database. This will help a lot your process, but in general, for how to structure and design your CI/CD pipelines dealing with databases, I would point you to this white paper that will come out over the different channels we have. By the way, there's a link in this slide deck that I will make sure to show before the end of the session, where you will find that white paper over the next days.
One question from Nilesh is about supporting the full text search for the Office filter and the PDF filter. As of now, there are no plans to support those filters, because as you can imagine, it is a database offering. So as of now, there are no plans available, right, Silvano?
Which is correct. As Borko, is that available in managed instance?
In managed instance.
Sorry, what was the exact question?
Yeah, sure. So his question was about the full text search. Do we support PDF filters and Office filters?
Unfortunately, not. Yeah, just the same level of functionality as in SQL database.
Okay.
Sorry. Yeah.
Okay, thank you.
Okay, there's a quick one. Which is best, Azure Serverless or Azure SQL Database? I'm assuming Azure Serverless means Azure SQL Database Serverless. So those are basically the same. So to be clear, Azure SQL DB Serverless is exactly the same technology behind the scenes, which is just adding the serverless flavor, which is capable of providing flexibility in terms of how your database instances will be charged depending on your query workloads and database interactions. Plus, it's introducing this concept of auto-posing, so you can switch down your database instances when they are not used. So behind the scenes, it's the is the same product and technology. It's just another flavor. And again, depending on your needs and your requirements, you may want to use a serverless instance or a traditional provisioned ones. It may save you some money on one hand, and then simplify some management aspects. At the same time, it's important to say that today serverless is only available for general purpose type of instances in Azure SQL Database. So if you need business critical or hyperscale, today serverless is an option which is not available for those different service tiers and performance tiers.
All right. There's a question from Pawan, and he wants to know whether if I have a database on-premise in MySQL on my desktop, can I migrate to Azure SQL? And is there any code change required? So you can definitely migrate to SQL, which means the SQL PaaS offering. But in your case, if you do not want to do any code change and just lift and shift your code, you can also look for a PaaS offering, which we have, which is for MySQL. So if you look for offering which is there for the MySQL, that essentially will, and it is called as Azure Database for MySQL. You can look for that offering, and that is going to fit more than the lift and shift of your code. So I'll put a link in the follow-up as well. There's a follow-up question for me, which I answered. You have mentioned earlier that Azure SQL offering will be latest and the greatest, but will this force developer to constantly change his or her code depending on the bugs or out of support feature in long run? This constant update of the new version for offering will support backward compatibility. Are these versions we can choose? No, you cannot choose the version. But you do have an option to change the compatibility of the database. But the code is always latest and the greatest. So which means you'll be running the SQL version which is not released yet, essentially. Yeah, so you can change the compatibility. If there is a syntax change under the compatibility, you can always change the compatibility mode and run the older syntax. But it is going to work the way it has been working in the past.
Just to add one aspect here, basically the core promise of our price services that are running latest and greatest version databases and managed instances is full backward compatibility for the workload. So yeah. Yep. Don't worry about that. I can use some time to answer the interesting question. Is there an option to run the production database and the development database and keeping those synced without affecting the production data? Basically, there are multiple ways you can explore. One interesting thing that you can explore both in SQL database and managed instance is actually running the point-in-time restore. So you can create a point-in-time restore copy of your production at any time without any impact to the performance of your production database. And then with managed instance, you can actually do that even across subscriptions. So you can run your dev test instance on a dev test subscription and then production on production subscription and even get the financial benefits. There are other ways to explore data sync between the production and the dev test, or in case of managed instance, you can also consider having transactional replication, right? So definitely different ways. Point-in-time restore is minimally or basically no impact to production database at all.
Great. So just again, we are reaching the top of the hour. Just a few additional couple of questions here. For example, this is Anonymous from Anonymous. Are there any upcoming feature for optimizing bulk insert and rebuild index afterward? You may be referring here to things like ordered column store. If I interpret the question, ordered column store is already available in Synapse Analytics and will be available in SQL database as well in the future, if that is the question. Another question from Anonymous is, will the read scale out feature be coming to the lower pricing tiers, or will stay to premium only? Well, there is a technical aspect to it, right? So premium today will offer a given amount of replicas included in pricing. So for now, that will stay on premium. And
hyperscale, sorry, Silvano.
And hyperscale, of course. Yeah. Sure.
Yeah.
Sure.
Yeah. Thanks.
All
the
right.
firewall configuration, yeah, just the very last one. Is there a plan to make firewall configuration easier in order to open Azure SQL for other Azure services? For example, there's a way to open Azure SQL Firewall for Data Factory integration runtimes. So yes, and all these new enhancements and configurations will be mostly designed around a private link. Private link is a new feature that we have available in Azure, and all the services now, public services now have the ability to basically get private IP addresses where you can design your networking configuration between applications to Azure SQL and implement all the networking rules and accessing, for example, from Data Factory integration runtimes on a private network, your own database instances. Right? So that's the direction we are taking for the future, and most of these new enhancements and improvements will be built around private link for the future. Okay, I think we are running out of time. I want to first of all thanks my colleagues here, Balmukud and Borko, for the support during this session, and thank you to the audience. Again, a lot of great questions. It's impossible to answer all of them, but again, a big thank you to you. There's a survey that will come after the meeting, and these are just a few pointers, a few links that you can use to get more information and upcoming articles and blog posts. And again, thanks all for your participation. Hopefully, it's been helpful for you, and have a great continuation with Microsoft Build.